All right, so in this section on 11.8, we're looking at expected value. So what you're going to learn, you're going to learn how to compute the expected value. You're going to use expected value to solve applied problems, and you're going to use expected value to determine the average payoff or loss in a game of chance. So expected value is a mathematical way to use probabilities to determine what to expect in various situations over the long run. So this isn't just one little short period, it's over the long run. Now, the expected value is used to determine premiums on insurance policies, weigh the risks versus the benefits of alternatives in business ventures, and to indicate to a player of any game of chance, gambling basically, what will happen if the game is played repeatedly. Now, the standard way to find expected value is to multiply each possible outcome, whether you win $5, lose $20, or whatever it is, by its probability, and then you add all of those products together. And we use a letter E to represent that expected value. So let's look at a simple example first. It's equally probable that a pointer will land on any one of four regions, numbered 1 through 4. Find the expected value of where the pointer will land. All right, so what we have is we have an expected value, and it's equally probable that they're going to land on one of four regions. So we've got, you know, four regions. So if the whole thing is 1, it's going to be a quarter here, it's going to be a quarter here, it's going to be a quarter here, and a quarter here. So the probability is a quarter for each region. And remember, that's region 1, region 2, region 3, region 4. For no other reason, you can go in any order, but that's how it is. And so what we do is we take the probability times what number it is. So we're going to take 1/4 times 1 plus 1/4 times 2 plus 1/4 times 3 plus 1/4 times 4, and that will give us a probability. Now, if we think about that, that's equal to 1/4. That's 2/4. That's 3/4. That's 4/4. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. And so this is equal to 10/4, or if we write it as a decimal, 2.5. So this is where the pointer is expected to land in the long run. Okay, so it's going to land, somewhere probably in the 2.5, so it's going to land right on the line there. So that's the expected value is to land there. Now that one doesn't make a lot of sense because that's a spinner. And what we'll do is we'll come and try one now with a fair coin. Okay, so a fair coin is tossed 4 times in succession, and then its probabilities and everything are here in the table. And this is for the different number of heads that can arise in those 4 times you flip it. Now we're supposed to find the expected value for the number of heads. All right, so the expected value is going to be what? Well, we just take the number of heads, 0, times its probability, plus the number of heads times its probability, and we just keep working our way across or down. So 0 times, and it looks like 1/16, plus 1 times 4/16, plus 2 times 6/16, plus now we have 3 times 4/16, plus 4 times 1/16. Okay. And so here we have 4 and 12, that's going to be 16, and 12, 28, 29, 30, 31, 32. So it looks like 32/16. Well, that's just 2. So the expected value is to have 2. So we're expecting to uh, flip 2 heads is what that means as far as in the long run. So if it asks what will happen in the long run, well, the expected value is to have 2 heads. Okay, so let's stop there and then we'll come back for some more.